Wow, wow, wow. Really helps when the camera actually works. I swear I actually tested everything before I hit go here, but let's turn up the exposure a little bit. Let's see if we can't get a little bit of a brighter picture here. Guys, it is so good to be back. Thank you for joining me for Tech Talk Tuesday. We're starting 2022 pretty strong, I think. Been really looking forward to getting back into it. I've got a lot of really fun ideas for this year for us to discuss. And for those of you who are regular visitors, for those of you who are new, thank you for coming. Welcome. And let's dive right in. Going to start with just a couple of quick housekeeping items. So number one, thanks for being back. It was a rough year last year. We had a little bit of a weird schedule towards the end of the year, but I think, like I said, we got a good track going. So for those of you who are coming back, respect. It's good to see you again, and I promise there's going to be some really interesting content on the horizon here. Rebrand. So some of you may have originally known me as the Son of Moog. I've rebranded to Serious Rollerblader. Really, the reason is I'm just trying to swing from one side of the nerd pendulum to the other. So rather than outing myself as an enormous Star Trek nerd, I'm instead, sorry, I'm just messing with my camera settings here. I'm instead outing myself as a serious rollerblader. So anyway, excited about that, guys. So if you didn't recognize my name, you're like, who the hell is this guy? Hi, ex-son of Moog. Another housekeeping item, YouTube. So I've been getting a lot of people messaging me online after they see that I've done a show, but they have missed it or they have obligations or, things are going on. We're all busy. And they always ask me, dude, how do I check this out? Where could I watch this if I can't see it live? Got some great news for you. We're starting a YouTube. So it's going to be YouTube/Serious Rollerblader, where I'm going to put all of the Twitch shows, maybe do a little bit of processing, some editing on them just to cut them down to make them a little bit more cogent for a non-live audience. But yeah, really excited to launch that. And last housekeeping item, we are back every week, every Tuesday for Tech Talk Tuesdays, pending any serious circumstances or illnesses on my part. I'm extremely excited to start a very consistent upload schedule and keep that rocking and rolling, unless things, really get boring and no one wants to hear me talk anymore. So without further ado, guys, thank you for joining me. Really good to have everyone back. We're going to jump right in with some interesting technology news. So we'll come back to this one. Super exciting stuff. So for those of you guys who have come to the channel before, come to hang out, you know that I've been talking quite a bit about the James Webb Space Telescope and all of the incredible opportunities that it is going to afford us as we peer not only into the depths of space, but into the depths of time as we start to understand the cosmic background radiation better. We'll be able to see through dust clouds that we were never able to see through before. All kinds of incredible, wonderful, exciting things coming our way. Now, for those of you who've been following, we had the launch of it on December 24th, Christmas Eve. So it's a really, really great Christmas present to see that go up into space. It has about a 30-day journey from it to get to where Earth is to the L2, Lagrange point 2, where it will be orbiting in a semi-synchronicity with the Earth and the Sun, so that it's far enough away from us so that it doesn't have any of the light of the Earth polluting its sort of cone as it looks into space. Now, as you can see here, this is a live tracker of where Webb is at right now. This is actually kind of cool. So it is, what is that? That's a lot. That's a lot of kilometers from Earth. And it's 95,000 kilometers to Earth's or to L2 orbit. So it's getting really close. Very, very close. 93% of the distance has been completed. It's going at about, what is this, 0.24 kilometers per second. I don't know why they don't just put it in miles per hour, kilometers per hour at this point. But anyway, some of the most exciting stuff about the deployment, though, is the sun shield, as well as some of the instrumentation. The sun shield has deployed successfully, which was a huge concern, or it was really the nail biter, I guess you could say, of people who've been following this, because there's a significant number of points of failure or things could go wrong, and they all didn't go wrong, which is sick. So it's the sun shield has been deployed. The mirror segment deployment is ongoing. So what you can see here is the actual mirror segments and sort of how they're aligning themselves. Again, all of this has to happen very slowly, in a very controlled manner, so that there's no cracks or breaks in any of the fittings of these very precisely tuned instruments. We watched a really cool video last year on one of the Tech Talks about precision machining, and it gives you a little bit of insight in just how precise these instruments are, these pieces are, and how things have to fit together. So it's extremely excited that the sun shield has fully deployed, and there's a couple of other big things that were happening. So to kick off Tech Talk Tuesday, we're gonna watch a video by Dr. Becky, who I love her energy. Some of you may have seen. There's a popular video going around when James Webb launched. Astrophysicist watches the launch. And it's a wonderful video of a scientist just being super excited at the wonder and marvel of what we are as a species, technologically capable of. So without further ado, I'm going to let Dr. Becky do some talking about the James Webb Space Telescope. Really, really, again, enjoy her content. Highly recommend that you check her out. Thanks, Dr. Becky, for providing us with great videos like this to watch.
Decollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
Happy New Year, everybody! I hope you enjoyed the launch of the James Webb Space Telescope on Christmas Day of all days as much as I did. I still can't quite believe that we're finally here, to be honest. It's been a long time coming. So I just wanted to take a few minutes to just update everybody on where the mission is up to, what's going on now, what's next after the launch. And there's three things that I wanted to pick out and mention specifically. The first one is that the estimated lifetime for the James Webb Space Telescope for science is a lot longer than we thought, which is possibly the best news you could have ever received, right? So if you watched the launch on Christmas Day, or you watched my live reaction to it midway through cooking a turkey, you will have heard the word nominal a lot from the mission controllers. And I got very excited about the word nominal, and the reason why is because the better the launch went, the less fuel that they had to use up. For example,
this is a huge point. So the one thing that is super fascinating about space exploration is the precision in which the calculations are done, and the amount of the lack of wiggle room they have for consuming certain resources. So fuel is obviously an incredibly finite resource, and it is critically linked to the long-term operation of these instruments or these telescopes. In order for them to continue to maintain their orbit, to move around, to essentially maneuver and navigate, if you will, that fuel is consumed. So if we can get the rocket or the whole assembly itself out into space faster and more efficient, all of those fuel savings can then be dumped into extending the life of the mission, which is super exciting. So I love that she's getting stoked about this. This is great.
If the trajectory of the rocket or the craft once it was released, wasn't quite on course, they would have had to burn a little bit of fuel to bring it back on course, a course correction. Or for example, if the rocket was rolling or precessing or something like that, they would have had to do a course correction. But the launch went phenomenally well. I mean, you could see like the trajectory of the rocket as it was going up lined up perfectly with where we wanted it to be. There was barely any corrections that needed to be made, which means less fuel was used up, which means more fuel for the future when it's actually doing science operations, which means it can do science for longer. So they did have to do 2 minor course corrections, one on the 25th of December and one on the 27th. But after those had been done, NASA and ESA could then basically sit down, run the numbers, analyze how much fuel do we actually have left. Bear in mind, we still have to actually get the spacecraft to L2, where it will actually orbit the sun and actually do its science operations from. But how much fuel do we have left, and how much time does that mean that we can run for? And then in early January, they actually announced, and I quote, that James Webb will have significantly more than a 10-year science lifetime. This is such a huge deal for those of us in the astrophysics research community, right?
Just to be clear, why that's something that's always important to remember when we talk about things is having an understanding of proportion or proportionality. And so when you take into account that this incredible device was basically sent out to space to last for 5 years, like that was essentially the life of the mission. It was like 5 to 7 years that they were going to get out of it. To be able to extend that to 10 years, it's fucking crazy, guy. That's sick. That's sick. Go NASA.
Because, and we were told that, in the worst case scenario, well, not the worst case scenario, the worst case scenario would be we'd have no telescope, but the best worst case scenario was that James Webb would go for 5 years, right? And we get 5 years worth of science observations from it. In the best case, maybe we get 10 years. But the fact that the launch on ESA's Ariane 5 rocket was so precise and there was so few corrections needed, we're now looking at this longer than 10 years figure. And the reason that it is so woolly, it's more than 10 years, is that you can't quite put an exact number on it because there's going to be a lot of factors that do affect that eventual lifetime, in the long run, in the long term, right? But
so one of the factors that might play into account, and this is something that you when you learn more about things like the Hubble Space Telescope and other space instruments and probes that are out in space, NASA comes up with incredibly creative ways of saving power and optimizing systems. And even though there's an enormous amount of engineering that goes into ensuring that these things are well built and meant to last, when they're out in the field, there's things that you see or learn that you maybe couldn't have predicted, or you're just oh wow, this thing is doing a better job than we thought it would, or maybe even this thing isn't performing quite as well as we'd hoped it would. And so what they can do is they can make little adjustments to their systems and subsystems and maybe squeeze even more life out of it, and even making executive decisions. At one point they might decide oh, we're going to actually turn off certain instruments. So the ones that are the biggest energy consumers, they might say we're going to shut that down completely and basically put it in an inoperable state so that we can never turn it back on, and then we're going to reroute that power. So that's a possibility in terms of how they could extend the life of the telescope out.
The fact they used the phrase significantly more than 10 years suggests to me we could be looking at 15 years worth of science operations with the James Webb Space Telescope.
Sick.
Which would be, amazing, right? It would mean more data for more people, more science would get done, and we would learn even more. The second thing I want to mention that was a huge milestone was that one of the detectors, so the instrument on board that is actually going to, record the light that the telescope collects, has been successfully switched on in space, right? The first of 4 instruments to do so. So if you remember from my video on the James Webb Space Telescope, it has 4 instruments in total, and I actually spoke to Sarah Kendrew, who worked on development of MIRI at ESA in Baltimore. So after speaking to Sarah for that video, it was even more special to hear that MIRI had, not only switched on in space, but also seemed to be functioning okay as well. And that is just the first in many, many, many steps that the MIRI team will take to make sure that everything is functioning okay and working. That's what they call the commissioning phase for all these instruments.
Okay, we need to check out something really quickly here. James Webb. MIRI. So let's take a quick look at what MIRI does for some perspective here. Because we covered these before, but...
in the universe and their first stars, as well as the composition of the atmospheres of extrasolar planets. During the journey, the deployment of the 6.6-meter primary mirror is a delicate and unique operation. Its huge 5-layered sun shield, the size of a tennis court, allows the telescope to cool down to around 50 Kelvin. After a cruise of 30 days, Webb reaches its orbit around the L2 Lagrange point, 1,500,000 kilometers away from the Earth. This is a stable and cold
I thought it was only 1 million. I guess it's 1,000,005.
environment, which are the necessary conditions to observe infrared radiation with unprecedented sensitivity. Webb is equipped with a series of 4 instruments located behind the primary mirror. The MIRI instrument is composed of a...
By the way, this video is fucking sick. Like, I'm sorry, the production value on this is incredible.
camera and an integral field
So
spectrometer,
cool.
both observing in the mid-infrared between 5 and 28 microns. The optical system of the camera, designed by the French team, is made of 5 mirrors and a filter wheel which selects the infrared radiation. The images are formed on a detector cooled down to a temperature of 7 Kelvin or minus 266 degrees Celsius.
Jesus.
The study of exoplanet atmospheres.
So just a little bit of perspective. The measurement of absolute zero, which is like 0 degrees, not 0 degrees, 0 Kelvin, in which theoretically atoms just stop moving. Like, that is how low the vibrations are. 7 Kelvin's pretty fucking cold, okay? Like, that's
Planets
crazy.
orbiting other stars than the Sun is one of the major objectives of MIRI. For that purpose, it uses 2 different observing techniques. The first is a new technical innovation called phase mask coronagraphy. The
Okay.
coronagraphs of MIRI consist of a mask located at the entrance of the instrument and a diaphragm placed in the filter wheel. The objective is to attenuate the light of the central star to observe the very weak signal emitted by an exoplanet, similar to the principle of a solar eclipse.
So, to give you some perspective, and I'm more than likely like bastardizing the shit out of this, but if you've ever tried to look up in the sky and the sun is in the way and you can put your thumb kind of over the sun and then all of a sudden see like a plane flying through the sky, that's basically what it is. It's the equivalent of like a very, very high-tech thumb.
MIRI will be the first instrument in space to implement this type of coronagraph.
Very cool. Very cool. Like,
This technique-
like corona, like the corona of the sun, like around,
It allows us to observe young and warm giant planets orbiting at several astronomical units from their star. The second technique is the infrared spectroscopy, observing the transits of planets with short orbital periods. With this technique, MIRI can record the light from the star filtered by the planet's atmosphere as it passes in front of the star, or the light emitted by the planet itself before it eclipses behind the star.
Cool.
The obtained spectra contain valuable information on the planet's effective temperature, the molecular composition, and the presence of clouds. While gas giant exoplanets will be the primary targets of MIRI, it will also be possible to detect small rocky planets with this technique. Thanks to the capabilities of MIRI,
TRAPPIST is an interesting system. We might actually go down the rabbit hole a little bit on this one here.
and the Webb telescope, researchers will be able to better understand the formation of exoplanetary systems, as well as the physical and chemical characteristics of their atmosphere, and perhaps even begin to study the conditions of habitability on these worlds far from our solar system.
Okay, we are going to go back to Dr. 1 second here. Where is she? back to Dr. Becky, and then we're going to switch really quickly to look at Trappist, because there's some really interesting stuff to talk about there, and there's a new YouTuber I've found that I love his content. I would love to have him on the show one day if it was at all possible, to get him to come talk about science. I would be so honored. But anyway, we're going to listen to Dr. Becky and then go on to Anton.
As well, but it's definitely the first step, and so it was a very exciting piece of news.
Hello,
and last but not least, as of yesterday, 11 days past the launch, we now officially actually have a telescope in space. Now, many of you are probably confused by that because it's been in space for 12 days now. So what do I actually mean?
Sorry, guys.
Well, the James Webb Space Telescope is essentially a double-decker bus parked on a tennis court, right? Just to give you an idea of the scale of this thing. It didn't fit in a little skinny rocket, you know, that's designed to be nice and streamlined to get it up off the ground. So it had to be folded up in order to fit, and it is now unfolding in space. This was always the most nail-biting bit. There are 344 single-point failures in this entire unfolding process. If any of those went wrong, that's it for the whole mission. We have nothing. Now, for an excruciating 7 days over New Year, right, from like late December to early January, they were unfolding this huge tennis court-sized sun shield designed to block infrared radiation from the sun.
Now, just keep in mind, while they're doing all of this like unfolding and stuff, this is after they essentially dropped the telescope, and like it had quite the vibration go through it, and like something else, I think there was like some type of tightening mechanism or clamp or clasp that sprung open and caused some issues as well. So there was a lot riding on this thing working properly, and there were a couple of good reasons to believe that like something would go wrong. So it's an incredible achievement
from the sun, essentially, and they were unfolding it and tensioning it, right, like pulling it taut. Now that had to be done very slowly so that there was no rips or tears in the sun shield, and in 5 individual layers as well. So they had to do this 5 times. This is why it was so nerve-wracking. That is thankfully now all complete, and it looks to be working okay because the detectors on board have recorded a temperature difference between the sun side and the opposite side where the telescope will actually be operating. On the sun side, it's still 50 degrees Celsius, whereas on the shielded side where the telescope will be, it's minus 200 degrees Celsius, which is great news. That's what we want, the kind of temperatures that we need. So it looks like the telescope is actually going to be able to operate as intended.
That is like a pretty like insane temperature variance when you think about it. Like that's wild, man.
For that, the secondary mirror fold out began, right? It's essentially a huge tripod that's about 8 meters or 25 foot long, essentially like the length of a big bus, right? And it's got a 75 centimeter wide mirror attached to the end of it that had to unfold into exactly the right position. That all seems to have gone swimmingly as well, and NASA announced it last night. It was possibly the best news you could get on a random dark Wednesday evening in January. And now that's folded out, we actually have something that's going to behave like an actual telescope. It is a telescope now that's folded out, right? Light can actually come in, bounce off what we call the primary mirror, that's, you know, the first point of contact that the light has with the telescope, bounce to the secondary mirror, and then get focused down to the detectors in the middle of the telescope. I mean, before that unfold happened, we essentially just had a bunch of really expensive high-tech kit floating around space, but no telescope. So with the announcement that that gone okay, you know, there was a huge sigh of relief from, I mean, the entirety of the astrophysics and astronomy community, because we are now past more than 75% of those single-point failures, and we don't have to worry about them anymore. Having said that, there are still a few steps to go yet, including folding out those, you know, iconic primary mirror hexagonal segments, right, that were tucked away during launch, and then also adjusting them so that...
So my understanding is that part's done. I do believe the mirrors have been, it's all about adjusting them now. Absolutely fascinating. Sorry.
Focus the secondary is correct as well. All that fold out should be done by the end of this week, right? Like by Sunday the 9th of January, we should know if everything is okay. And then my heart rate can presumably finally slow down. If you want to follow all this, NASA has a great website where you can see the timeline of the mission, know what distance it's at from Earth and from L2, and what stages are left to go in the fold-out. I'll link it down below for you. Plus, there's usually a live stream for all these different stages of fold-out, you know, all the different milestones as well. You can see what's going on in Mission Control Room, and they're usually on NASA's YouTube channel. I've actually got notifications on the NASA web Twitter account, so I don't miss them when they're happening. I will have another update on JSWST for you in 2 weeks' time on my Night Sky News episode for January, so keep an eye out for that, because by then we're going to know, how this mirror segment adjustment has gone and if everything's okay, and it will be very, very close to its final orbital position of L2, where it'll actually be doing all of its observations from. And then we'll be one step closer to first light with the James Webb Space Telescope.
So sick. Thank you, Dr. Becky. Respect. Absolutely love her content. Please check her out, guys, if you get the chance to. Shifting gears, but also not. I want to quickly look at this awesome video from Anton Petrov, who is a great, he uses Space Engine, which is an app we're going to fly around in shortly. He does a great job of explaining space stuff and does it in like a super exciting way. So we're going to dive into his video about TRAPPIST, because I'm pretty sure that's one of the systems I'm sure that James Webb is going to be taking a look at. So
person, this is Anton, and today we're going to be talking about TRAPPIST-1 system once again.
And surface pressure is likely to be
a very exciting discovery that both presents us with a new mystery and also allows us to study these beautiful planets, opening up a lot of new opportunities for new studies. Specifically here, the scientists discovered something unusual about the densities or the composition of these 7 planets. But in case you forgot what TRAPPIST-1 is, well, to date it's probably the most exciting planetary system we've discovered so far. Located about 40 light years away from us, which is, in terms of galactic distances,
not that
actually
far,
relatively close. This is the system discovered only a few years ago, when the scientists realized that there were 7 very unique and very unusual terrestrial planets orbiting around a red dwarf, with all of the planets being relatively similar in size, relatively similar in mass, and also being located in a somewhat exciting region. 3 or possibly even 4 of these planets are in the habitable zone of the star system, with all of the planets here now officially confirmed to be terrestrial, meaning that they're not super-Earths, they're not gas giants, they're actually planets like Mercury, Mars, Venus, and Earth. But all of this took years and years of observations, analysis, and thorough understanding of how orbital dynamics work around these planetary systems. Now, originally we discovered these planets via the Kepler telescope by essentially looking at the shadows passing in front of the star. This is how the scientists were able to determine the sizes of all of these planets. Knowing the size, though, is not really enough to determine, for example, the mass or the density. You still have to actually find the mass of these planets for us to learn anything else about them. One way of trying to discover the mass of planets is by looking at how much the star wobbles as the planet passes around the star. By measuring the amount of wobble, or basically the amount of motion of the star across the night skies, we can then determine the mass of this planet. But this usually mostly works for larger planets like Jupiter-like objects. So for a gas giant, it's relatively easy for the scientists to determine mass this way. For smaller planets, terrestrial planets, especially planets that only represent a fraction of the total mass of the star system, that method would not really work very well. You would need to have an extremely accurate telescope, which doesn't actually exist yet. Just to give you a comparison of mass difference here, the total mass of all of the TRAPPIST-1 planets represent about 0.02% of the total mass of the star system. Now that's almost nothing.
Yo,
that's actually
Eric,
kind of
what is up? How's it going? Welcome, welcome.
Mass in all of the moons of Jupiter compared to the mass of Jupiter. Which
I'm going down a little bit of a rabbit hole, I'm not going to lie. It's talking about the James Webb Space Telescope and how exciting it is. And one of the things that came up in that video is the TRAPPIST system, which is super fascinating. And I'm letting my boy Anton school us a little bit on the particularly interesting little part of space.
Which, by the way, does imply that these particular planets may have been created in a very similar way to the moons of Jupiter. There is actually a very unusual similarity in different orbital patterns and also just in the way that the planets behave compared to the moons of Jupiter. And so by just knowing the sizes of these planets, how did the scientists determine their mass then? Well, there's actually a very interesting method known as TTV, or transit timing variation. This method also relies...
So there's an enormous amount of scientific information that we get. Oh, yo, Eric, thanks for the follow. Appreciate that. From the transit. So you might have heard of like the transit of Mercury or the transit of Venus. It's essentially when a planet, you know, goes across, like my mouse is going across this sun right now, and what we can see those planets as a result of either the little shadow that they make as they go across, or from incredibly great distances, we'll see like the dimming of a star. So based off of certain behaviors in how we see light dim up or down, or the intensity, or there's a variety of different factors that I'm not 100% aware of, but based off of those calculations, they're able to determine the size and the mass of a planet based off of kind of the shadow that it casts as it goes across the sun. So, you know, a lot of our observations of the universe really are light, right? Whether it's visible light, infrared light, ultraviolet light, and so to you know, like you want to use lights like the other suns out there to help illuminate our way through the cosmic tapestry that we have the pleasure of looking up at with these fancy instruments. So take it away, Anton.
Relies on measuring the shadows of these planets passing in front of the star. But in this case, when there's another object in the star system, such as for example another massive planet nearby, it will start pulling on this planet, thus affecting when these shadows appear compared to our original predictions. So in this case, because of the pull from this planet, the transits now, the shadows, will have slightly different timing. There will be a timing variation. Now this transit timing variation is a very, very precise and actually very interesting method of determining the total masses of all of these planets. And so by looking at transit timing variations of all 7 planets, after only a few months, the scientists were able to calculate very precise masses of each of these planets, where the transit timing variation made a lot of sense. And now we know as a fact what the mass and the size of each of these planets is, with the recent study being the most accurate in determining both. And once you know the size and the mass of each of these planets, finding the density is just a matter of division.
So what's super fascinating about this, and why, again, JWST is such an exciting technological innovation, and why I continue to try and like just hype the shit out of it, because I don't think people realize just how much it's going to blow the lid off of the images that it will produce will be incredible. They'll be mind-blowing, but the really exciting part is the science that's going to come out of that. And I think there's going to be some really deeper understanding of the universe and like what is actually out there, right? And what was I going to say? So when we make these observations of systems like TRAPPIST, let's say, right? We watch the TRAPPIST system. What we're using, it can take a significant amount of time depending on not just like the star that we're looking at, right? Because not only are we like looking at a star, but like our globe is spinning, and we're also spinning through space. So there's like a lot of timing involved, right? In making sure that we can get like clear shot for whatever that distance is, right? Also on Earth, we have to use, radio telescopes. We have to use visible light telescopes, ultraviolet telescopes that go through the atmosphere, right? We lose a lot of resolution as a result of that. We also, if you look at Hubble, like Hubble's outside the atmosphere, and it's an incredible instrument, but James Webb is like way, way, way better than Hubble, like in every way, shape, or form. The mirrors are bigger. The detectors are better. It is a complementary instrument to Hubble, as opposed to like Hubble is not dead. They're not turning it off. They're like, no, we're still going to do science on Hubble. It's just we're going to do different kinds of science on James Webb. And so when we look at systems like the TRAPPIST system, and you kind of get an appreciation for how we measure these things on Earth with our current technology, right? Think about how much finer and improved our resolution not only will be from like a telescopic perspective, right, that we can just see things better, but just like our depth of understanding of these systems and being able to either say like, holy crap, like we were way off, like we have a better telescope, turns out we're super wrong and a lot of assumptions we made are incorrect and blah blah blah, or right, it will continue to sort of reinforce and help steer pre-existing knowledge. So we might look at that system and be like, oh wow, we calculated that mass within like a very reasonable like threshold of error, I guess you could say, right? So I think that's what gets me so excited about James Webb, is that it's going to let us, all of these incredible scientific discoveries that we're making today are about to get put on steroids. So take it away, Anton.
Dividing one value by the other, you get the total density of each of these planets. Now, what's really unusual is, of course, the recent discovery and the recent confirmation that the density of each of these planets is very unique to anything we've seen so far. Each of these planets seem to have extremely similar density to each other, and that's something we've never seen before, with the overall planetary density being very, very similar to planet Earth and also very similar to each other. It's defined as being about 8% less than the density of Earth and the density of Venus. And remember, here we're talking about 7 unique planets, 7 planets that most likely also have somewhat different surfaces, somewhat different atmospheres, and potentially somewhat different composition as well. But in this case, they do have very similar density, and that just kind of doesn't make sense right now. The reason it doesn't make sense is because of the examples we have from the solar system. And actually,
so it's a really some people, when I have conversations with folks about science, right, and about these incredible instruments that we're shooting into space, and when you look at the price tag on something like James Webb, right, you say, okay, it's a $20 billion telescope just to launch it into space, let alone to operate it and do science on it, right? What is that going to do for people down on the ground? Like, how are we going to be able to connect that to making, our lives any better down on Earth? And I think it's difficult sometimes for scientists because a lot of science is kind of divorced or far removed from the Yeah, can I see my can you give me an ROI calculation on them, please? What am I going to see? I'd like to see my 8%, right? Respect. So, you look at these different initiatives and like, how could this benefit me? Like, how can this benefit, people's material conditions on Earth? And though, again, I agree that some of this stuff is far divorced. There's a really good podcast with Lex Friedman where he interviews, I think it's Catherine DeClure is her name, and she's like all about exoplanets, like that's her thing. And one of her favorite exoplanets that she talks about is I love that. One of the exoplanets or moons that she gets really excited about is the moon of Io, and I didn't know anything about Io until I heard her talk about it with like such passion. And Io is a sick planet, or sick moon. You know what? I'm just going to, fuck it. Let's just let her talk about Io. If I'm going to go down rabbit holes, guys, we're going down these rabbit holes together. Lex, Catherine, I think it's like that, Catherine DeClure. Yes. Okay.
Life. Long,
so
0 or 1.
You're right, that'd be...
Where is Europa? Likely Earth. I found Venus, Mars. Earth is a planet. Weather patterns. I swear there was like oh yeah, fuck, here it is. Sorry, it's like right in the beginning. That's why I remembered it.
Can we just zoom in on certain things? Like, let's talk about Io, which is the moon of Jupiter.
Right.
Okay, it's like epic. There's like volcanoes all over the place. It's from a distance, it's awesome. So can you tell me about this moon? And you're sort of a scholar of many planets.
This is Io,
but that one kind of stood out to me. So why is that an interesting one?
For so many reasons, but Io is the most volcanically active object in the solar system. It has hundreds of active volcanoes on it. It has volcanic plumes that go hundreds of kilometers up above its surface. It puts out more volume of magma per volcano than volcanoes on Earth today. But I think to me, the reason that it's most interesting is as a laboratory for understanding planetary processes. So one of the broad goals of planetary science is to put together a sort of more general and coherent framework for how planets work in general. Our current framework, it started out very Earth-centric. We start to understand how Earth volcanoes work. But then when you try to transport that to somewhere like Io that doesn't have an atmosphere, which makes has a very tenuous atmosphere, which makes a big difference for how the magma degasses. For something that's really small, for something that has a different heat source, for something that's embedded in another object's magnetic field, the kind of intuition we have from Earth doesn't apply. And so broadly, planetary science is trying to broaden that framework so that you have a kind of narrative that you can understand how each planet became different from every other planet.
So, though there might not be obviously like a direct correlation between like our observations of volcanic activity on a moon like Io and how volcanoes behave on Earth, what it can reinforce is like a much greater understanding of how planets form in general, the gradients of those planets, and thus those insights that we get from like, okay, we can like kind of get a lot better understanding of how this works, which helps us understand a lot better how that works. And again, I'm making a fairly tenuous argument here, but I think these are the type of scientific achievements that we should get excited for, that we should fucking heavily hype up. And that's why like these projects are so exciting. And so I'm particularly stoked for, again, I don't think we're going to get pictures out of James Webb until at least the summer, they might have been saying, even towards like the end of the year. And this is all depending on how the deployment goes. But then, considering it's been going like pretty smooth so far, I'm extremely excited. So anyway, let's let Anton finish his little spiel about TRAPPIST, because there's some neat findings in this one.
Really, from any star system we've seen so far. So just as a comparison, let's take a look at the solar system and the density of planets here. The highest density of all of the objects is our own planet Earth. The density here is about 5.5 grams per centimeter cube. Then we have the neighbor Venus, then we have Mercury, and then we have Mars, with the density of Mars being about 3.93 grams per centimeter cube. Now usually by knowing these densities, we can then determine what the composition of the planet is and also what sort of materials...
Is it just me or is this Earth? I feel like unless this is Uranus and there's just like the Earth, it's misaligned. I don't know about you guys, but that's really tripping me up.
We can expect to find both inside the planet and possibly even in the upper regions of the planets. Now in this case, we know that Mars, for example, doesn't really have a very large iron core. Whereas Mercury, despite its smaller size, probably has a much larger core. And then once we start talking about gas giants, the density suddenly drop. With the least dense object of all being Saturn, the density here is actually less than the density of water. It's about 0.68 grams per centimeter cube. And
So I do have one thing to say about this. I've got lots of things to say about a lot of things, which is why we're here, I guess. But what always fascinated me as a child, in like thinking about planets and like how planets formed, and what fascinates me is that like not only is there an incredible wide variance in like what planets are made of, and we know that from our direct observations of our neighbors like Saturn, Jupiter, and Neptune. Like not only are they made of different stuff, but just like their core composition is vastly different. And it has always fascinated me as a young one, and even to this day, on like how do planets form and seem to suck up certain elements, and like why is Neptune made mostly of this and why is Jupiter made mostly of that? I'd love to know the answers to these questions. And again, hopefully things like James Webb can answer some of those. But what I think is like super exciting is like our ability to look into other solar systems and other like faraway stars and find these like similarities between our systems, like to look at a place like TRAPPIST or Alpha Centauri or whatever and say like yeah, they got round globe things too, and they seem to follow like very similar rules. And this is where a lot of the hype from the people who are looking for life out there get that hype from, right? They're like, hey man, if it can be here, it could be anywhere. So whether or not there's some super hype YouTube videos trying to say like James Webb is gonna find life, maybe we'll watch that and I can like give my critical debunking of why I don't think that's going to be the case, but we'll pick that up shortly.
Here, that's kind of what we expect from most of the planets in the typical star system, and for the most part we've been seeing something similar in other star systems as well. Even if you were to look at the moons of Jupiter, their densities do vary quite a lot. Not as much as the density between Earth and Saturn, for example, but still quite a lot. Between 1.83 grams per centimeter cube for Callisto and 3.53 grams per centimeter cube for Io. But somehow none of this seems to work for TRAPPIST-1 planets. Each of the planets here, despite the distances to the star and despite their location in the star system, seem to have relatively similar densities, even if their size or their mass is different from the planet next to it. And at the moment, nobody really knows how to explain any of this. There are 3 potential explanations, but none of them are really conclusive. The first explanation here is really in regards to the cores of these planets. All 7 of them might have relatively similar iron cores that are slightly smaller than the core of planet Earth, with the iron cores inside each of these 7 planets being roughly around 21% of the total mass of each of these planets. But having a core that's pretty much exactly the same as the core of the planet next to it is very unusual, or it would be almost impossible to explain this in any of the modern planetary formation theories today. Why would these planets have exactly the same internal structure? Currently, there is really no way to explain this. And also, just to give you a comparison, Earth has the core that's about 32% of the total mass, and it's that iron core that gives our planet such a high density. And it's also the biggest iron core of all of the terrestrial planets in the solar system. The second explanation that
that's actually that's a good point. And I wonder too, like something as much of he can be a little bit too much for me sometimes. Neil deGrasse Tyson, I love the guy, but he can be a little too smart sometimes for his own good. His whole spiel about stardust, and truthfully, like the universe is predominantly composed of hydrogen, I do believe, and I know that there's a couple of elements that fall after that, but all of the heavy elements that we get to take advantage of on Earth come from exploding stars. It comes from the forges of fusion, and one of the reasons why we see a lot of iron and why we think that iron cores are such a critical part of planetary formation, which would also explain why it seems to be consistent among multiple solar systems across the speckled galaxy, is essentially all nuclear fusion reactions end up with iron. Like that's like iron and lead, I do believe in that, but they essentially end up in one of those 2 states. So it makes sense that we would see large deposits of that jettisoned from an exploding supernova star. So I mean, I'm an idiot, but like maybe a really, really, really big ass star blew up, and there just happened to be a shit ton of iron in that particular little gravitational whoosh, and one of those stars picked it up, and that's why you see like a consistent density. I don't know. I'm not a doctor, but
makes sense is maybe because all of these 7 planets are filled with iron oxides. You know, that same stuff that makes the surface of Mars red? But unlike surface of Mars, all of this would be going all the way down to the core. Now that's a very good explanation as well, but it still doesn't make sense that all 7 of them would have this. We know, for example, that several moons of Saturn and Jupiter, such as Titan right here, do have a kind of a strange mixture on the inside, where the silicates are mixed with different water compounds and form these unusual structures on the inside that give them very specific densities.
Interesting.
Something similar could happen if you were to mix metals, or iron in this case, with various oxygen compounds. But there should still be some sort of a density difference. It's still kind of difficult to imagine that all 7 planets would have exactly the same densities and exactly the same structures. And the last and the third explanation here is, well, it's also kind of unusual, but kind of makes more sense. In this case, the scientists imply that it's possible that the large amount of mass of each of these planets is made out of water. And more specifically, the middle planets here would most likely contain some sort of a liquid ocean.
For a hot second, I thought he was going to be like, or the third option is that like the telescope is broken and the data we have is bad and this is just that's what I thought he was going to say, but it's like, no, water core. Okay, water core, cool.
The outer planets would be made out of really large amounts of ice, but the inner planets, specifically the 3 inner planets, would have a very large atmosphere of water gas, which would also in turn increase their overall size. Kind of similar to the very thick atmosphere we see around Venus, for example. And for this explanation to work well, each of these 7 planets would have to have a very specific amount of water on the surface. It doesn't really matter what they have on the inside, they'll probably still have different cores and different iron composition, but the presence of water has to differ in order for them to have these properties that we're observing and to have the sizes and the masses that we're seeing. Which also implies that at least 3 of these planets potentially have a liquid ocean on the surface. But here on some of these planets, this would also mean that water would have to represent about 5% of the total mass of the planets, especially the outer 4 planets. Whereas if you were to look at planet Earth, our planet only has about 1% of mass being water. But of all of these 3 ideas or 3 propositions, the one about water actually makes the most sense right now. Although it's also possible that it could actually be a combination of 2 or even 3 of these propositions. So maybe there is a lot of water on some of these planets, but they also contain a lot of iron oxides as well, and possibly even some sort of an iron core. So all 3 ideas and 3 propositions currently kind of make sense. Nevertheless, all of these discoveries of TRAPPIST-1 present the star system as one of the most unique star systems we've ever discovered, with 7 planets that are extremely interesting for many different reasons, some of which of course being the fact that they probably contain liquid oceans, and also don't seem to be very different from planet Earth in terms of the mass, size, and of course density. Now whether they actually look like this picture right here, and whether we discover signs of potential life here, is unfortunately not something we're going to know until we take a look at these planets with more powerful telescopes. Luckily, James Webb telescopes should be able to tell us a lot more about this star system in the next few years. But for now, that's all we know about this unusual star system.
I knew it. I knew it was coming around to that.
New things about it every single time there's a new study, and we seem to be discovering new mysteries as well. But hopefully, in the next few years, we'll have a definitive answer about what's really happening in the star system and whether we're going to find something absolutely incredible on the surface of these unusual planets. One day we might be able to visit them, but it's probably not going to be anytime soon. But anyway, that's all I wanted to mention for now. Check out the study I mentioned in the description below and all of the additional information there as well. If you've enjoyed this video, subscribe, maybe share this with someone who loves learning about space and sciences, maybe come back tomorrow to learn something else, and maybe support the channel on Patreon or by buying the Wonderful Person t-shirt that I'm wearing right now, that you can also find in the description. I'll see you.
Yo, respect, Anton. Not only am I subscribing, but I'm definitely gonna buy that t-shirt at some point. Love this guy's content. I think he's great. He has such a awesome way of like approaching science and making it like super accessible to people, which I think is important these days. So love Anton, love his stuff. So excited. Before we switch away from space, because I do have a couple of interesting tech news things that we want to talk about. There's the Activision buy by Microsoft that some folks poked me about earlier today. There is the Log4j stuff. There's a great hilarious story about some like shitty doxing website where the people who submitted like documents to essentially got doxed themselves. So we'll have a look at that. But just to cap off our conversation on space, we're going to run this great Karst Gazalt video. It ran not long ago. It was on one of the Tech Talks, I think, that I had before we ended last year. So I'm sorry if you guys are watching for this for the second time, but it's pretty sick. So please enjoy why we should not look for aliens.
This is incredibly...
Oh, God, so loud. Mark, come on. Volume check, please, for the love of God. Sorry, guys.
The universe is incredibly big and seems full of potential for life, with billions of habitable planets. If an advanced civilization had the technology to travel between the stars at just 0.1% of the speed of light, it could colonize our galaxy in roughly 100 million years, which is not that long given the billions of years the Milky Way has existed. So, in principle, any spacefaring civilization should be able to spread rapidly over huge sectors of the galaxy. And yet, we see nothing, hear nothing. The universe seems empty, devoid of others. This is the Fermi paradox, which we've discussed in more detail in other videos. Confronted with the seemingly empty universe, humanity faces a dilemma. We desperately want to know if we are alone in the Milky Way. We want to call out and reveal ourselves to anyone watching, but that could be the last thing we ever do. Because maybe the universe is not empty. Maybe it's full of civilizations, but they are hiding from each other. Maybe the civilizations that attracted attention in the past were wiped away by invisible arrows. This is the dark forest solution to the Fermi paradox.
I love these guys' videos, are great.
The way of life. The hunter awakes in his hiding place and carefully listens for suspicious noises from the thick undergrowth before he gets up. Another night has passed without incident. The forest is dark and full of fog. He considers calling out to others to end his loneliness, but stops himself at the last moment. What if they are like him? All living things seek to survive, secure resources, and multiply. Their greatest obstacle are other living things that share the same objective. Competition between species favored the survival of beings with advantageous traits. Our ancestors were inventive, competitive, expansionist, and greedy for resources, which led them to winning the competition for our planet. Today, most other animals are so utterly at our mercy that we wipe out about a dozen species a day, just as an unintentional byproduct of how we like to run things.
That's a
But
nice way of
humans
putting
are
it.
more than individuals. From us, cultures emerge that also compete with each other. Competitive and expansionary cultures spread faster and further and merge with, subdue, or destroy others. If we look at our history, it becomes clear we are dangerous. Not just to others, but also to ourselves. Our human nature has driven us to take over every corner of our planet, and soon we will look to the stars, both to expand our domain and ensure access to ever more resources. And then we might stumble upon others trying to do the same thing. It's likely that the competition of life also takes place on faraway planets, so it's logical to assume that an alien civilization that came to dominate their planet would be in some regards similar to us. But if they're similar to us, they too may be dangerous. The implication. As the hunter sneaks through the dark forest all alone, he knows that there might be others like him. He can't know their intentions, if they are aggressive or not. The hunter knows he would kill to ensure his own survival, so he has to assume that they would too. And it might be that if he stumbles upon another hunter, the one that shoots first survives.
From my understanding, there's actually a fair bit of not I don't want to say serious research, but game theory and other types of academics applied to the conception of what if we were to run into technologically advanced civilizations? Would it be a we shoot first? Would they shoot first? If you're a fan of Star Trek at all, there's the whole Prime Directive conversation. Would we even expect aliens to make contact with us, given that we had not reached, a certain level of sophistication? There's quite a lot of interesting science fiction behind this, and also good science as well. A fun clip that I'll play at the end, one of my favorite perspectives on meeting an alien for the first time. But
None of this means that conflict is unavoidable. So far, the progress of the modern world seems to have made us more peaceful, not more violent. Maybe this is true for other civilizations too, that eventually progress means less conflict, not more. Different alien.
So what I will say about this is, if we make like a very basic assumption that other life has similar energy constraints and that it evolved out of the ability to take one energy source and convert it into another, a lot of those types of energy conversions involve like a stability, equilibrium, symbiosis with environments. And so we would hope that the similar benefits that we have gotten from being a more stable, less violent type civilization would also be emblematic in another type of like alien civilization, even if their biology was radically different, right? Aliens, high-tech weapons versus a random 2 with that 4. Yeah, it's just like, it's kind of like, I don't know if you guys remember Independence Day, like one of my favorite parts of Independence Day. And like anyone, even though that movie came out in what, like 94 or something like that, it's just, it's so like, there's the part where there's a news session on like the LA News Network, and it's like, citizens, please do not shoot at the spaceship, right? Like just people like anyway. I was gonna say, if we're talking about huge expanses of time behind this theoretical civilization, it's highly possible they have reached a state where they seem to be working towards. Yeah, no, totally. And I mean, also there's the other piece of the whole Fermi paradox is that there might just be a limit to a civilization's ability to self-propagate. Like, if we can't get off the rock of Earth, we can say with a pretty high degree of confidence that like the sun is going to explode. Like, even if we could press the resources on Earth to an infinite level of availability through hyper advanced recycling technologies, maybe if we got like a Star Trek style ability to synthesize matter and all that kind of shit, even if we did that, we're pretty sure the sun's going to explode unless we could also fix that problem too. So in order for human beings to sustain themselves, into the 100 million or billion year life cycle, it's going to take some exploration. And maybe because of the rarity of habitable planets and the like you said, just the sheer expanses that we have to be able to traverse to even get to another planet or another system, let alone one another, there might just be a natural sort of barrier and almost like a dampening field that keeps life just kind of in place in its local area. Totally possible. There's also a possibility that some other civilization pressed a button one day that like lets them access some dimension that's like warp speed, and they can just travel from system to system. And that's why people in rural Idaho see flying saucers. So I'm open, guys. It's 2022. Mine's got to be open these days.
Alien civilizations also should vary from the mild and peaceful to the malevolent and militaristic.
Yes, that is true. That's 100% true. There is like actual, again, like behind game theory, they're just like, it makes sense for other civilizations to come in less hot or peaceful because of the mutual aid and the benefit, right? And it's like, hey, it is a natural consequence of evolving to that level of technological sophistication. Like, I think, again, going back to Star Trek, like if you imagine, at least in the Next Generation, it was a little bit different, I've been told, in the later, instances, but in the Next Generation, they're eventually like, we've solved like poverty. Like there is like no one wants for anything because energy is abundant, food can be created on command. Like there's no concept of people going hungry anymore unless it's like for a fast or something. And so if we are able to remove certain material constraints from our day-to-day lives, that of like food production, water availability, blah blah blah, it truly would transform our society and the things that we focus on, and the types of art that we engage in, and just how potentially creative we could be as a species. So we can also imagine similar benefits happening in other parts, or 100%. Dude, I love that you mentioned that. I just downloaded that movie recently. I downloaded it legally. Legal. So I downloaded it legally, and great movie. It's so good. I forgot, like, I remember it being like super star-studded and being an incredible movie, and then I forgot, like, oh my god, Danny DeVito's so good. Anyway, I stray.
The existential problem we're facing is that when we meet others between the stars, we have no way of telling who is peaceful or aggressive and what their true intentions are. Similarly, they might not understand or trust our intentions, even if we tell them that we are peaceful. On top of that, if we did discover another civilization and they discovered us, the light years between us would mean years of communication delay. Both sides would be in a state of uncertainty, wondering if the wisest move is to just attack, because there's another serious issue: technological explosions and the first strike advantage. We don't know where the limits of technology are, but we do know how much technological progress matters in war. A few hundred or thousand years can turn conflict with uncertain results into a one-sided massacre. Caesar's legions would stand no chance against Napoleon's army with their cannons and muskets, which would be eradicated by artillery from the First World War, which would not stand a chance against today's drones and guided missiles. So the power level of different civilizations may vary massively, and even if not, between the time it takes us to detect another civilization and us saying hi, we might already be hopelessly behind on the tech tree. Which is bad enough, but the nature of interstellar conflict makes this worse. If your opponent is light years away, sending an invasion fleet takes so long that by the time it arrives, it might be hopelessly obsolete. So war between civilizations might be just about eliminating the other to remove an existential threat to yourself. Someone else who might be so scared of you that they attack the first chance they get.
So this kind of feeds into what you're saying, exactly that, right? Like, there is that possibility that if let's say some alien ship pulls into the atmosphere, they're not using telescopes, so time dilation is not a problem, right? They're getting a live and direct view of you. So let's say they look at Earth and they're just like, look at these fucking monsters, right? And if they don't have like some kind of a if they don't have some kind of an appreciation or a shared history, like if a technologically advanced civilization didn't go through the same kind of turmoil and war and all the things that human civilization has been progressing through as we progress, we would hope that they would have some like empathy, but some like, oh yeah, they're just like, it's kind of like, oh, they're just finding their truth, bud. Like they're just on their journey, like they'd be like, yeah, they're like fucked up and they're killing each other and they have bombs that could blow up the whole planet, but like, so did we. And that's part of the process. Now, whether they would give a shit or not, it really comes down to their intentions. There is a really great clip, just to shift gears, because I feel like you bring up a very interesting point, just to shift gears really quickly. If anyone has seen the movie Sphere, with Dustin Hoffman, Sharon Stone, what's his name? Fucking Samuel L. Jackson is in it. There is a scene in which they make contact with an alien that has been on the bottom of the ocean for about 300 years. So they're making contact with this alien through a computer. So I'm gonna play a very, very quick clip of this for commentary. This is covered under fair use, guys. But they basically make contact with this alien.
Friends, in the 8,000 years of recorded history, this is a first. You are now online with an alien intelligence.
You gotta be kidding. You must have messed up the translation.
No, I don't think so.
If this translation is right, this alien sounds like an idiot.
Well, that's something to consider, a stupid alien. Well, they must have them.
Well, I will admit the message is a little childlike, but actually it's quite perfect. I mean, it's short, to the point, non-threatening. Kind of the way you talk to a small child or a dog. Look at this.
He's making a speech. Ask him for his last name.
What?
I want a full name for my report.
This is great. This is great.
I'm not putting in my report that I lost a crew member on a deep sat expedition to find an alien named Jerry. Please, Jerry?
Harry, I think better tell him that we're enjoying it too. Ask him where he's from.
Where are you from? I make a journey, you make a journey. We make a journey together.
I think Jerry's channeling Deepak Chopra.
A journey from where?
Excuse me.
This is it.
He's happy.
He's crafty.
What happened?
Oh, damn, I think we lost him.
We're not alone. We are definitely not alone. Harry, it's trying to make contact with us.
Well, whatever it is, it was inside that sphere. Now it's out and free to act.
What do you mean by that?
Free to take over our computers, free to call us on the phone, free to come over and knock on the door if it wants to.
Physical presence.
What are you thinking about, Norman?
That last part where he
Here
said
it
I
is.
am
Here it
happy.
is.
Well, don't you want Jerry to be happy, Norman?
Honestly,
Yeah, what's on your mind?
I would be happy if Jerry had no emotions whatsoever. Because the thing of it is, once you go down that road, here's Jerry, an emotional being cooped up for 300 years with no one to talk to. None of the socialization, the emotional growth that comes from contact with other emotional beings.
So,
What happens if Jerry gets mad?
Oh, what happens if Jerry gets mad? And that's the question, right? Like, if we were like, and imagine just that. Like, imagine we did run into an alien, and it's like, I've been flying through space for 300 years. I haven't, this is the first time I've talked to another emotional being. That alien might be kind of fucked up and might not be able to interact with us very well. So the entire there are just so many layers to the conversation around alien life in the universe. And what I say, if you ever come back to the stream, or if you're a regular follower of the content here, I essentially subscribe to there 100% is life in the universe. It also is possible that the universe is just cooling down and getting calm enough to a point now where complex life can actually form, because life can't really evolve and form if like suns are exploding and gamma rays are hitting planets, or you have no atmosphere. Like, things need to cool down and chill in order for like the party of life to like get bumping, you know what I mean? So we might be at a time in just the age of the universe in which life is just starting to emerge. So life might be totally possible in other planets, but it's also possible we are some of the first life. And that's why we might, like, we should take a particular responsibility with that, and like being good stewards of the planet, and like, just trying to be good people as much as possible. But anyway, that's one of the ideas behind the Fermi paradox right now.
In this environment, the only way to guarantee a win is to strike with such force and speed that the target has no chance of survival or time to counterattack or escape to seek revenge later. The stakes are the highest possible, with no room for error. If we assume that the majority of civilizations live on planets, that leaves them pretty vulnerable. All you need to do is throw something massive at a planet to make it uninhabitable. So the ultimate interplanetary annihilation weapon is probably something like a relativistic kill vehicle, a missile shot at a planet at a significant fraction of the speed of light. For example, a missile the size of a person going 95% the speed of light has as much energy as all nuclear bombs on Earth. If you shot a few dozen at the civilization you wanted to wipe out, success would be fairly certain.
Oof.
Even a single hit would suffice.
That's brutal.
This is not that absurd of an idea. A civilization only slightly above us on the Kardashev scale would have enough energy to send multiple strikes against every planet it suspects of harboring life. What makes these weapons so sinister is how much they favor a first strike, since they would be so fast that it might be impossible to protect yourself effectively against them once they're launched.
This is where game theory becomes kind of interesting, because it deals with a lot of the theory behind like first strike and like should you strike first, and here is why you should strike first. If your mindset is around assuming the other party for one reason or another has malintentions, or you just don't want to take that risk.
Conflict between civilizations may not be lengthy affairs, but rapid winner-takes-all situations, where the first one to shoot wins. This makes any civilization an existential threat to any other. And if every civilization is an existential threat to every other, there may be only two kinds of civilizations out there: quiet ones and dead ones. So, what should we do? Should we worry? It's unlikely that anybody has noticed humanity yet. The radio signals we've transmitted in the last 100 years traveled a relatively tiny distance and have long decayed into unreadable noise. At our technological stage, if we don't actively try to get noticed, and if nobody specifically looks at our pretty unremarkable solar system, we'll stay hidden. But one day we will venture into space in a serious way, and need to consider these kinds of questions again.
There's our little solar
system. We don't know if there are others or if we are going through the forest alone.
That is Jupiter,
but we have no way of knowing for sure. For the time being, it seems the best we can do is to carefully listen. And even if we see others step into a clearing and make themselves known, we should not reply right away, but carefully watch them from the undergrowth. Perhaps we are also thinking about this all wrong by allowing our primitive brain that evolved in the context of the gruesome competition of life to conjure fears of predatory aliens all around us. Maybe the fact that we are looking at the universe like this is a sign that we are not grown up yet as a species. There could be a friendly, welcoming community of alien civilizations waiting to hear from us when we are ready. As for now, the good news is there is actually little we need to do. We just need to be thoughtful about the signals we send out into the galaxy. We need to watch the sky and learn more about our galaxy, our forest. Because whatever the nature of our forest is, full of dangers or friends, or nobody at all, only careful observation can tell.
Yeah, this is a good view of like our essentially our local group here. So if you see, like, you know, this is, again, we're kind of zoomed in on Jupiter right now, but there's our solar system there, and then outside of it you can kind of directly see solar systems in our immediate proximities. This is you often hear about Alpha Centauri. It's because it's real close. It's something that we've observed multiple times using all kinds of different telescopes. It's a system I think we know a particularly lot about because we've spent a lot of time looking at it. And each one of these is a sun with some planets around it. And then, as you zoom out and really start to appreciate just like the sheer density of just this local group of stars and solar systems, and that is just a speck of the least dense part of our galaxy. Like, if you compare where we are, to anywhere else closer into the spiral, it's kind of insane just how much matter and how much mass is out there. So, really great video. I'll let Kirk's result finish it off. Sorry, I forgot. There's a good point to the end here. So,
let's do that. At last, the hunter reaches a clearing and finds a comfortable position. Slowly, the sun melts the fog away. Lost in thought, he admires the vegetation until suddenly he is eye to eye with another hunter, frozen in terror just like himself. His mind is racing, considering all the different options. The hunter takes a deep breath and makes a decision. Maybe the only way out of the dark forest is to step into the clearing together. And with this hopeful picture, we say goodbye to the year 12,021 of the human era. It was a wild year to say the least, still much more fun than 12,020. Kurzgesagt had its most successful month ever and published a book. We tried a lot of new techniques and really got into Blender and Cinema 4D, hiding more and more 3D in our videos. We have so many ideas for next year and big and ambitious plans that we can't wait to share with you. And all of this was and is possible because of your direct support. Thank you so much. Kurzgesagt only works because of you.
I love Kurt.
So
like,
in tune with
the
the
shit.
end of
Please
the year,
support them,
we've designed
guys.
a few
Like,
products
subscribe,
that will help
all
you
of that.
to visualize your place in the universe. Our very shiny The Night
Their merch is actually very sick. Like, they've got some really, really cool science, like star charts, and they've got some great books on the immune system. I covered them on a previous tech talk that we might come back to at a later date, depending on, the state of the world. But great content. Please like their channel, buy their shit. Absolutely sick. I think we're going to shift gears a little bit. We're going to change pace. We're going to talk about stuff a little bit different than space. We're going to talk about some stuff that's happening on Earth. And maybe before we get deep into the cyber security BS, I'll start with the great, hilarious article on Flashpoint here. So If just to start out really quickly, the concept of doxing is to take the personal identifiable details of a human being and put them out on the internet and associate them. So, for example, I, on Twitch, am known as Serious Rollerblader, and if someone was to dox me, they might hand out, my exact date of birth, what city I live in, potentially my address, where I work. They might give out my siblings or my parents' names, something like that, right? And that information that can be used against you in particularly like shitty and negative way. So Doxbin, it's I guess like a company. It's a website. They were essentially I'll read through the article here, but they were a place where people could paste and expose other people. So there's a subreddit that I particularly like called Leopards Ate My Face, and it's all about Schadenfreude, and watching just like the Schadenfreude of the situation, which I saw on Leopard Eats My Face. It was a particularly great article. So we'll read through it here together, okay? Let me just zoom in a little bit. So on January 5th, a threat actor on the illicit forum XSS posted a leak allegedly sourced from doxbin.com, a well-known pay site where users would post doxing information, including personally identified information on individuals and family members. In the post, they noticed that data was not taken by them and originally appeared on a Telegram channel used for communication by Doxbin users. So Flashpoint analysis, what was leaked and what it means. Flashpoint analysis analysts conducted an analysis of the alleged Doxbin database and identified a total of 41,000 unique user entries. Fields in the dataset include username, email addresses, and passwords, in addition to user agent strings as stated above. So passwords is kind of fucking crazy. Like that. Oh my God. Okay. Like I talk about this a lot on stream on how it's really important to compartmentalize your online identities. And so, if you're using your credentials for something, even especially like I 100% do not endorse trolling. I think it's just like there's so many people out there to troll. Like, let them do it. Don't be one of them. But if you're going to do some kind of stupid online activism or whatever in which you don't want your identity to get tied back to you, like, don't use your personal email address, and sure as fuck don't enter a password that you use for anything else into this. So, you know, if people were signing up for a DocSpin account, they might use an email, a password that is the exact same one as their Gmail, as their work, as their whatever. So having that data exposed can be incredibly crippling depending on, again, like the depth of the data and how clear the passwords are, whether they're in plain text, whether they're hashed, whether they're hashed and salted. And if you guys have questions about what those terminologies are, what they mean, we can get into that as we go down. But anyway, Cache page DocSpin's terms of service page states the only real information we obtain is your user agent string, which is wiped from our server after 7 days, which suggests that the administrators of DocSpin lied about the information they collected on users. Very typical. See this all the time. The volume of unique usernames within this dataset suggests an average number of users on the site are interested in doxing attempts as compared to the broader illicit online ecosystem. Based on analysis of the types of email addresses that appear in the dump, most users are unlikely to be sophisticated threat actors. So what they're saying there is, if you are a sophisticated threat actor, which means someone who is attacking a system or doing something nefarious on the internet, and if you have a level of sophistication to your techniques, you will use certain types of email services or methodologies to obfuscate your identity as much as possible. And people who are security researchers and they can see that. It's kind of like matrix code. Like they're just like, oh yeah, no, this person's using Proton Mail or whatever. So that clearly person is like kind of knows what they're doing in terms of remaining anonymous, versus people who just use their like personal Gmail account that's like on their Facebook or something like that. So threat actors within illicit communities that operate sites such as DocSpin regularly harass and conduct retaliatory activities against one another, including doxing or attributing malicious activities to the targets of their ire. Doxing can also be used as leverage or extortion against the administrators of a website. For example, in the past year, Flashpoint observed threat actors publish personal details of the owner of the Russian language marketplace Hydra and the administrators of the Russian language narco forum Legalizer. That's wild. So, what's a dox? The goal of doxing is to obtain... Goal doxing is to obtain any and all information pertaining to the target. Valuable information in so-called name and shame campaigns include the target's full name, address, phone number, employer, family and friends' names, and compromising pictures. Think nudes, or even think like things like a party you shouldn't have gone to, or like a person you shouldn't be hanging out with and you lied to a significant other about. It's not even a cheating thing, right? The priority of information of doxers is dissimilar to that for hacktivists, who typically attempt to gain additional PII, such as date of birth, social security number, and financial information. Doxing techniques range from simplistic Google searches to use the more fee-based and or advanced tools such as Maltego and Intellis. In this capacity, most doxing attempts are conducted by inexperienced operators who infrequently validate their findings through cross-referencing or deductive reasoning to eliminate false positives. These shortfalls frequently lead to false accusations, misinformation, and putting non-affiliated individuals at risk. Is that all there is about it, eh? Oh, so where's the actual... I thought there was a data set. Man, that article is actually kind of lame. I want to know more about what the actual data set was. But anyway, yeah, I don't want to buy your stuff, guys. Sorry, no, not at least not now. Not who I'm working for. So fascinating. Okay, cool. So anyway, like, awesome. Love to see it. So now you have, and this is like out on, I think, like the internet. It's available to people. So if you ever had suspicions about being doxxed, you might be able to now tie that to an individual, which could result in you taking like legal action against them, especially if you have their email address, their IP, any of the information can be tied back to them. It's very easy to make like connections between those things and make legal cases. So speaking of things in the security space, I do want to quickly talk about the Log4j vulnerability, because this is something that, a little bit of background for those who are new on the stream. By day, I'm an IT professional. I help maintain large businesses' infrastructure, systems, software development, wide variety. I'm what I like to call an ocean wide, inch deep. I know a lot. I know very little about a whole lot of things. And one of the things that instantly came up when this vulnerability was exposed to us was quite the scramble to get it fixed. So we're going to talk about what Log4j is, and Wired wrote a pretty great, decent article. I should say, it's a good article on why it will haunt the internet for years. And we can expand a little bit more on what Log4j is down the road if anyone is curious about the more specific technical details of how it works. But I feel like they do a pretty good job of addressing it here. So the first thing to mention is that this is a vulnerability in open source Apache logging library. So Apache is a web service or web server operating system. It is used everywhere. It is incredibly ubiquitous because it's open source, it's free, and it's good. It's very good at making highly available web servers to run your website, your e-commerce, your business, your whatever. Apache is ubiquitous in the IT world, and so a lot of platforms, a lot of systems, and a lot of things run on Apache web servers. And Log4j is a Java logging tool that is part of Apache web services. So the reason why I'm trying to shine a bright light on that there is because it just has you'll hopefully you get appreciation for just how serious the scope of this is, right? So a vulnerability in the open source Apache logging library, Log4j, sent system administrators and security professionals scrambling over the weekend. Known as Log4Shell, the flaw is exposing some of the world's most popular applications and services to attack. And the outlook hasn't improved since the vulnerability came to light on Thursday. If anything, it's now excruciatingly clear that Log4Shell will continue to wreak havoc across the internet for years to come. Hackers have been exploiting the bug since the beginning of the month, according to researchers from Cisco and Cloudflare. But attacks have ramped up dramatically following the Apache's disclosure on Thursday. So let's talk really quickly about how security vulnerabilities are typically disclosed. When someone who is what we call a white hat, which is a hacker, but they're a good guy, finds a vulnerability, they almost always go to that company and say, hey, I found something and you better plug this hole, because if I found it, someone else can find it and use it in a bad way. Other times they trip across someone actively using it as a baddie. And that's not the way that you want to. You want someone who's a good person who trips across it and finds immediately, ooh, I found this. You should have this. No one should have this. Get rid of this. Versus someone who's been I've been robbing the bank for months and I'm going to go rob other banks, and it's kind of hard for you to stop me from robbing all these banks, is the analogy I'm trying to make here. So, what a lot of security organizations do and companies is as soon as you find these vulnerabilities, you are telling everybody about it. It's on blast. It's guys, upgrade your shit. There's a vulnerability. But the side effect of that is that now all of a sudden a bunch of hackers are oh shit, there's a fucking vulnerability, Log4Shell, let me just click. Oh, what system can I wreak havoc with? Or whose day can I fuck up today? And that's the problem, is there's this almost flare up, this inflammation activity that happens upon the disclosure of these vulnerabilities. So so far, attackers have exploited the flaw to install crypto miners on vulnerable systems, classic, steal system credentials, burrow deeper within compromised networks, and steal data, according to a recent report from Microsoft. The range of impacts is so broad because the nature of the vulnerability itself. Developers are logging frameworks to keep track of what happens in any given application. So to exploit Log4Shell, an attacker only needs to get the system to log a strategically crafted string of code. From there, they can load arbitrary code on the targeted server, install malware. So the idea behind like code injection or malicious code triggering is, if I can, it's almost like a secret word that if you could just say like a word to someone and they would just give you their keys or give you their money or like open their door. That's kind of what it is. So they're able to use an exploit, because what this is a logging application. You want your systems to have logs so that when something breaks or goes wrong, developers and engineers can go into that code and be like, okay, what bro? Okay, we need to, yeah, that makes sense. Like, we have to fix that. That's going to keep happening to people, right? This is how we improve software over time, by logging things and then having access to those logs. What someone figured out is by like writing something into the log, it's essentially unlocking the door for me. And now I can get in that system. I can run malicious code. I can start to install whatever I want. And this is one of the things that like people have to understand, that like when we are building systems from like a high like cybersecurity standpoint, it's like, imagine building like a boat. Right? And we talk about, like, I use this analogy all the time, the boat being plugged and having leaks. We cannot let a drop of water in the boat. As soon as there's the tiniest leak, it's over for us. Like, we have to have 100% moisture repellent in order to keep this shit out. And that's difficult to do, right? That's really hard for a lot of organizations to pull off. So anyway, the rain, excuse me. Blah, blah, blah. So yeah, anyway, it's super easy to log stuff. So major tech players, including Amazon Web Services, Microsoft, Cisco, Google Cloud, and IBM, and also ServiceNow, have all found that some of their services were vulnerable and have been rushing to fix issues and advise customers about how best to proceed. The exact extent of the exposure is still coming to view, though less fastidious organizations or smaller developers who may lack resources and awareness will be slower to confront the threat. Meaning that, like, people who can't afford to patch their servers or don't have like really legit IT people will be basically at risk of having their systems compromised. And having things like, it's so funny that the hackers are like, yeah, they're stealing details and stuff. It's like, let's just install like a crypto miner on their computer and then use it to like mine like Ethereum. It's so fucking scummy. Anyway, what is almost certain is that for years, people will be discovering the long tail of a new vulnerable software as they think of new places to pull exploit strings, says independent security researcher Chris Frohoff. I love that name. This will probably be showing up in assessments and penetration tests of custom enterprise apps for a long time. The vulnerability is already being used as a growing set of threat actors by Cybersecurity and Infrastructure Security Agency Director Jen Easterly, and said in a statement on Saturday, shadowed the flaw is one of the most serious I'd seen in my entire career, if not the most serious, in a call with critical infrastructure operators on Monday. As first reported by Cyberscoop, in that same call, the CISA officials estimate that hundreds of millions of devices likely affected. Yeah. That's actually, I was, for a hot second, I was like, that's the worst. Like, there's been worse shit than that. I'm like, actually, maybe not. Like, it is kind of, it's not good. It's definitely not good. And what I will say is, I will tell you why I know for a fact that it's really bad, is because like a couple of, my organizations that I work for, I saw like instantly like responding to this, like just like patch. How many Apache web servers? Get it done. I don't care. It has to happen today. You're staying up till 4 a.m. I don't give a shit. Like it was all hands on deck. Anyway, why is this interesting? Why do I think people should care about this stuff? I mean, at the end of the day, what is important is that we as citizens, and I'm speaking from a Canadian perspective for any of my American viewers, but from a Canadian perspective, our government's job is to, make sure that we're not getting essentially put under undue danger, stress, threat, etc. And so I think it's important that our government demands from just security agencies and IT companies, etc., that like we're always going to have holes, we're always going to find vulnerabilities, but that we have to like have some standards and some best practices in how we secure IT systems, how we make sure that things aren't vulnerable. We need to have essentially good legislation that helps inform companies on like what their obligations are to make sure that they actually protect people's data, right? And so things like, and what I'm not saying that like, oh, if someone had a better policy, no one would be impacted by this. That would be ridiculous to say, because again, it's a new vulnerability that they found in the wild being used, right? So this stuff's going to happen. It's really about how we respond to it, right? And how we make it like, accessible for smaller organizations and stuff to be able to patch those things and respond to that. And also just make sure that we're investing in looking for this stuff, that we have organizations, and whether it's private organizations or public organizations, that are spending time and treasure and effort in looking for this stuff, exposing it, and bringing it to the forefront to continue to keep people safe. So I'm very passionate about cybersecurity. I think that the information systems that we're building, the internet, is incredibly powerful. It's a wonderful, magical tool. Like, there truly is, like, if you meme it all, the magic. Like, you've seen the art that comes out of this really weird fucking thing that we've built and sort of strung together. And I'm a big believer in, like, there's a lot of prosperity in what it can bring us. But we need to be educated in terms of what to expect from tech, right? And say, like, we demand secure systems. We want you guys to run code that isn't vulnerable. Like, I don't need to know, like, I mean, I do because it's for my job, but you guys don't need to know, like, the intricacies of, like, IT or data security. But you should demand that, your government knows, and that the people who are, essentially providing you with services and have your personal information also know. We should ask companies, like, how do you secure my data? Like, what are your IT practices? Like, and it doesn't have to be like, I want a list of your it's like, do you meet the gold star? And that exists in certain spheres of IT. Like, if you talk about credit card processing, like credit card payments, any credit card processing, there are some like really serious fucking heavy rules around the level of security and maturity that your company has to have in order to take credit card numbers. And if you fail those audits and your shit isn't up to snuff, they tell you to go fuck yourself. Like, it's as simple as that. They will block you from being able to transact money, right? So when it comes to the stuff like that, the standards are pretty high. But we need that for, like, our personal data. We also need that for to protect people, and given how digital our lives are becoming. Shifting gears a little bit. Great little article on classic BlackBerry phones. So I actually have like a QWERTY, I think it's a BlackBerry 9700. It is a sick phone. It is like one of my favorite phones that I have ever used. I would say, like, in terms of like an email device and like productivity, I will take it over an iPhone any day of the week. Unfortunately, they've turned them off now. Like, they don't work anymore. So apparently the old BlackBerry isn't going to be working as of January 4th. So they will stop running support for its classic devices. And that means any of its older devices not running on Android software will no longer be able to use data, send text messages, or access the internet. So one of the interesting things about BlackBerry and why it was successful in the security space when they first started out was because they had this underlying secure messaging infrastructure that also included, how they connect to a data network and all these other things. So what's interesting about this is they basically just shut that off. They're just like, hey, we're turning off like the BlackBerry features, like the things that make those old BlackBerries heartbeat. So it's kind of like the end of an era. Like, I was using a BlackBerry 13 years ago, probably, and I know it makes me sound like a little bit of an old fuck, but it was a great phone. Like, it was the absolute shit before iPhones were really much of a thing. Like, they existed, but they weren't nearly as hot, and you couldn't get nearly as, like, if you were in any like boardroom, high-end, like, business, bank, stock exchange, everyone had a BlackBerry. iPhones were like, okay, cool, you like to listen to your music or whatever. Like, sorry, I'm busy like running the world over here, right? That was kind of the BlackBerry vibe. So, absolute end of an era. Huge end of an era alert. Now, this next and possibly last story that we're going to talk about is actually no, not the last, maybe the second last story that we're going to talk about is about ichthyosaurs. So my friend sent me this clip about a giant sea dragon. He's like, yo, sea dragon's got to make it onto the tech talk. Like, I'd like to see some sea dragon representation. So we're talking a little bit about sea dragons from my pal. So ichthyosaurs are essentially marine reptiles, better known as fish flippers. Ichthyosaurs are sick. I actually see a fossil of one at the Royal Ontario Museum. There might still be one there. It's quite, like, you look at it and you think it's like, this kind of looks like a whale, but then you realize it's like, it's a reptile. Like, it's like a lizard. It's not a whale. It's absolutely wild. They thrive during the Mesozoic era. They appeared 250 million years ago, blah, 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 blah. Absolutely fascinating animal. Do we have any, like, pictures of what they look like? Yeah, they kind of look like fucking, like, alligator dolphins. Slightly horrific monsters. So apparently they found an absolutely huge sea dragon fossil in the English water reservoir. So they're about as long as a bus. And just to give you some perspective here, here's a little clip of, look at this thing. And again, just for some perspective, this is like a 250 million year old like piece of fossil that has just been sitting in the ground waiting for humans to find. It's absolutely fascinating. Super, super cool stuff. Anyway, the sea dragon. Ichthyosaur have been found in England's mainlands. The largest and most complete of its kind discovered in the UK. Okay. Ichthyosaurs were large marine reptiles, similar in shape to dolphins, but they grew up to lengths of 25 meters. The 10-meter-long fossil named the Rutland Sea Dragon was discovered in February 2021 in Rutland Water, about 106 kilometers northwest of London. It's thought to be 180 million years old. Wow. A conservationist at Leicestershire. That's not a real... That's... Like, where is One Cool Pigman? Is One Cool Pigman in chat? No, he's not in chat. One Cool Pigman, if you were ever looking at this video, how the hell am I supposed to say that? What is wrong with the oi bruvs? I'm sorry to be bruvophobic here a little bit, but like... Leicestershire? Like, I don't know. Like, why do you make words like that is just what I want to understand a little bit better. And I know you don't have a good answer for it, but anyway. Conservation at Stupid Word and Rutland Wildlife Trust Joe Davis found the ichthyosaur during a routine draining of the Lagoon Island for re-landscaping. Interesting. The find has been absolutely fascinating and a real career highlight. It's great to learn so much from the discovery and to think this amazing creature was once swimming in the seas above us. Known as sea dragons due to having large eyes and teeth, ichthyosaurs went extinct about 90 million years ago. Thank God. Those guys are fucking... They're creepy looking. Like, that is a... Like, that looks like a mean dolphin. Super mean dolphin. Anyway, ichthyosaurs, sea dragons, GTFO. Wow. Microsoft bought Activision, or are in the process of buying them. I don't know if this has to pass like what regulatory hurdles. I'm sure there will be something at the Federal Trade Commission level in which they're going to be like, hey, we want to make sure that you guys don't have a monopoly on gaming. I have some very preliminary and poorly thought out thoughts on this, which I'll get to in a bit. But apparently, like, this is kind of a big deal. It's a $70 billion deal. And what it really says about Microsoft, my initial opinion about it is what it really says about Microsoft is that they are, and they've said this, they're like, we're doubling down on gaming. We want to be the next generation and sort of push the next generation of gaming. Now, are they the right company to do that? I don't know. I hope so, because there's a whole bunch of companies that aren't the right company to fucking do that. And like, you get absolute, to pay homage to one of my favorite creators, Jakey, dog ass. You just get these dog ass fucking games that are like literal, like almost robbery. Like Back for Blood for me personally was like borderline robbery. Like borderline, I played it, I'm just like, okay, like I wanted to love it, and then after I played it a couple times, I'm like, I'm never gonna play this again. Like, you took my $80 in Canada, again guys, it's 60 in the States, it's 80 up here because whatever. And so, I ripped this game a couple of times. I've tried to play it again and just like I can't bring myself to like it in any way, shape, or form, which is maybe my fault. But anyway, I'm tired of dog-ass games getting produced by dog-ass developers. Battlefield 2042 is another example of pure dog-ass. So I hope that this deal will result in some kind of improvement in video games. Microsoft makes some fucking great games, man. Flight Simulator's tight. Like, there's stuff in their catalog that they're doing well. Game Pass sounds fucking awesome. It might even make me buy an Xbox someday. I mean, I've always been a loyal, PlayStation head, but like, there was literally a time when I had a bunch of disposable income, and I absolutely would have bought a PlayStation 5 like in a fucking heartbeat, but I didn't because I couldn't buy one. Fuck it. So anyway, just the availability of the console is like really, unavailability of the console is a problem, is stupid, and yeah, maybe it's time to rethink things, guys. I don't know, we'll see. Anyway, let's read through the article really quickly, and then I'll give some of my final stupid thoughts, and what I hope that there's another play here, and we'll see what that is. So Microsoft's $70 billion acquisition of Activision Blizzard doesn't give the maker of Xbox and the home of Halo control of everything significant in console gaming. Sony still stands apart with its strong stable of PlayStation exclusives, while Electronic Arts, Take-Two, and Ubisoft continue to jockey for position across all platforms. But it's damn close to everything. Since 2014, when Redmond shook $2.5 billion from the piggy bank to acquire Mojang and Minecraft, the company had been in an escalating buying spree that also bought a who's who directory of AAA gaming to its Xbox Game Pass library, now 25 million subscribers strong. Pillarized at the beginning of the Xbox One console generation in 2013 for a supposedly waiving interest in video games, Minecraft soon vowed, under the new head of Xbox Phil Spencer, that it would adopt renewed diamond-hard focus on the games, the good games, nothing but the games. So help him God, he's made good on that. Here are some of the major franchise developers and names that Microsoft now controls. Halo. I mean, they always have. Gears of War. Very sick. Minecraft, tight. Hellblade. I don't think I've played this game or know anything about it. Fallout, The Elder Scrolls, Wolfenstein, Doom. Oh, that's pretty sick. That's pretty huge. Now Call of Duty, Diablo, Overwatch, Warcraft, plus much more. Yeah, their catalog is intense now. Yeah, man. I mean, I think I am super curious about what Microsoft is going to do with VR. I don't know a lot about what they're working on. I'm a little ignorant in this space right now, but like considering like Facebook is going hard into VR. Okay. Apple is working on some kind of VR/AR glasses or goggles. We know that Valve, I think, has started to give up on their VR aspirations. The only other company that hasn't, and I could be wrong here, like hasn't really made much of a big VR play is Microsoft, particularly in the hardware space. And that isn't to say that they're going to, but, I think that they're going to make a very, very big move in that world in the very near future. And I'm not saying that this is the linchpin of that, but I think like this deal is an underpinning of some moves that they're about to make. So I'm super fascinated to see where they go with this. One thing I'll say, and like fuck Activision, like fuck Blizzard. It sounds like, and this isn't like, you know, as much as I've not been in the room with these people, I've never met these people, but Bobby Kotick as a CEO, in the way that he like facts on paper was completely useless in dealing with sexual harassment allegations, promoting a culture in which women were not able to feel comfortable, and I'm sure men too. One thing I don't understand is like, I see shit like that, and if I'm not in a position where I feel like it's safe to speak up and say something, like, that shit makes me uncomfortable. You know, I don't like seeing anyone bullied or harassed, right? And so, anyway, fuck him, and fuck him for, like, promoting a culture and sweeping fucking perverts under the rug and just, like, letting the fucking boys club get away with whatever it wants. Fuck those guys. Fuck Blizzard. What angers me more than anything, this deal, he will get a significant severance. So they'll be like, boom, you're out. I would say he's probably, like, honestly, I wouldn't be surprised if you saw like $100 million go in this guy's pocket, maybe even more. But time will tell. Those things, as far as I am aware, because companies like Microsoft are publicly traded, a lot of their finances and stuff like that have to be disclosed for regulatory purposes. Guys, we've been at it for 2 hours. It has been an excellent step back into the pool of tech talks and getting my feet wet again. It was like I said, last year was weird. The year ended kind of strange, but I've been really excited to sort of refocus my creative pursuits and hang with you guys and talk more about science and technology. I've got a couple of really interesting ideas in the hopper. It's going to take some time to get them fully to fruition. But in the meantime, every Tuesday, we're going to be talking about news in science, technology, watching cool videos, talking about interesting ideas, and hopefully having more people come and check it out and say hello and stop in and pop in and lurk and lock and do whatever it is that we do these days. Guys, thank you so much for coming to hanging. It means a lot to me. For those of you who stuck around, appreciate it so greatly. I am Serious Rollerblader. You guys are the best. Keep looking at the stars, and we'll talk soon. Be well, guys.